Hello and welcome back to the hinge tutorial. Today we're going to go over a few more details and create an assembly. Last time I was doing quite quickly and I don't want to spend too much time, but I went back and cleaned up things, named some of the features, which is always a good idea for when you're going to go back later and edit things. Also added some description on the less obvious variables. You don't have to do all of them, but it does help clean things up. One more couple things. Last time I didn't mention that, but I left the holes out because it's not that it's harder to do parametrically, but if you're designing a hinge, you can decide what logic to use to place the holes. But if you're going to buy a hinge, you probably want to just measure where the holes are, because you're going to need to know that exactly. So I wouldn't put in the holes without knowing exactly what the hinge is going to be. And there's maybe I'll go into that in a later video, but there's ways you could reuse this hinge model and add the holes separately, which would be a good way to do that. Another thing I want to do, it's not actually strictly needed in this case, but it's useful trick. It's a good workflow to know, so I'm gonna go over it anyway. Which is adding an explicit mate connector to make sure that the mate in the assembly is nice and stable. So I'm going to use a nice stable reference that is our original sketch to create an explicit mate connector. Owner part is going to be the leaf, and I am going to use our good old length variable to move it to the other end of the hinge. And the reason I want to do that is that the second leaf is going to mate with this end at the top here, and that way it will be whatever, if the cut for the knuckles somehow affected that end, it would not break the mate. So it's good practice to do this, even though in this case it's not strictly required. We're going to go into blank assembly, insert. I can just click on the whole part studio, and that will insert both parts. I'm going to fix the leaf, group the leaf and the pin, and I am to go Control C, Control V to add a second one. You don't have to rotate it, doesn't really matter, but it can be a little bit easier to see what's going on. And then I am to add a revolute mate between this mate connector that we created and the pin, because the pin should be a nice stable thing as well. And there we go. Now you could add limits to the mate, but there's a significant performance impact to doing that, and most likely when you use this hinge in assembly, you will want to control the rotation and the limits there anyway. So it's better, and if you use multiple mates, now you have multiple limits kind of fighting each other, and it's going to slow things down. So generally speaking, my advice is, if you're doing this, don't put the limits in and control the rotation of the mate at the top level. That would be my tip for this. One thing we could do is add configurations, because we created this really nice model. I'm not going to do all of them, but I'm just going to quickly show. Let's do an example with, let's just say the length. So I'm going to create a configuration in the part studio, create a configuration variable, call it length, default. I mean, I guess it doesn't really matter. And then I'm gonna go in here and set the length. And by the way, I don't know if you noticed, but there's a nice cross highlighting from the variable table. If you want to know where a specific variable is used, you can mouse over, and I will show you that. And you can even filter the feature list to only show the features that use the variable, which can be helpful for longer, more complicated models. Anyway, I was gonna right click on this and go set to length, and now I've got my configuration input and I can dynamically make the length whatever I want. Now I can go back in Hinge and select all the parts, because they are coming from the same part studio. I can change the configuration at the same time, and I can make a smaller hinge just like that. And I could even, there's a couple things I could do. I could create a configuration variable, or you can mix and match. So I have a configuration variable here that's continuous. I can adjust continuously the length, but maybe in here in my assembly, I just want a short and a long one. And what you just then need to do is configure, well, there's a couple different ways you can do it. You can go like this and set this. This is actually fairly quick, unless you have many parts. This is a good way of doing it. And obviously I want the same, oops, the same length in each one, and now I have a short and a long hinge, and here all driven from this. And well, this is turning into a bit of a configuration tutorial, but why not? I'm gonna add another one for the width as well. And we can go default to 50, sure. And that will be the width. Set, now I've got the other option set to width, and we're gonna do the same thing here. Add these in here, and I think, can I do it from here? I think I can do it from here. Right, I can use this and configure this. And I can also, generally, you can edit this pretty much, change the configuration, whatever dialog is open, you can still change the configuration on the fly, which can be nice when you're doing this. You can see what's going to happen. So for the long one, I'm going to set that to, let's say, 75. So now I've got my a short and a long version of my hinge, and apparently it did not set these to the same. Width is 75 here. Oh, okay, okay, so I did not have these configured. So that didn't grab all of them. So you kind of want to do it like this. And the pin, actually the pin does not need to be in here. So I can unconfigure this because the pin does not have a width. So now it's just a matter of making sure I'm using these same options for both of them. I mean, you could create an asymmetrical one for that matter, but now I have or maybe I should call them small and large. And now you've got two different hinges just like that. And you could keep going at the number of knuckles as well, and you could create, a standard and heavy duty with different size pin and material thickness and all that. Actually, I'm going to show that because that is kind of fun. It's a different kind of configuration. If you're coming from another CAD system, you might not actually have that. So now I do have to go in here and add that as well. So same thing, I'm going to do configuration variables in here. Again, call this pin diameter. Actually, we can have spaces in here. Default to 3. And add another one that will be the thickness. Default to say 1.5. Same thing. The quickest way to do this is to do it from here. Set the pin diameter, set the thickness, and basically what ends up happening is that we have these that are driving these. And you could, if you planned straight from the beginning, you could create these and skip creating these by setting the sketch dimension and everything straight to these configuration variables. You could have skipped that step, but I didn't want to confuse things too much. And then heavy duty, now I'm going to change, I guess I have to pick all of them. This, and then this. And now heavy duty hinge, we're going to go with 5 and 3, why not? It's going to be very big, 5 and 2.5. Pin diameter, that doesn't matter. I guess I might as well put them all the same so it's clear. But now, suddenly I have a regular or heavy duty version in small and large. So I have 2 things, 2 inputs, and I'm generating 8 possible configuration. And I could even do a medium that would be, 75, or sorry, let's say 60 wide by 75 long. 75 long, 60, 75 by 60. And now I have a bunch of different versions quickly using just 2 inputs. Anyway, that was a bit of it made sense to explore the whole configurability as well, because the whole point of creating a nice parametric model is to be able to change things like this on the fly. And you could do the number of knuckles as well, using the exact same idea. I'm not going to do it here. I think that's probably enough to... Oh, one more thing that could be useful is as you try to use this in assembly, this is not necessarily the easiest thing to mate, because I'm guessing unless your assembly has a reference for the actual axis of the hinge itself, you could mate here, but then it affects a lot of things. So it would be helpful to have a nice fixed mate connector. And what I would probably do is pick a good solid reference. So again, I think I would use the original sketch, because that's really the best thing, because that's the first feature, so it's not gonna just change around on you. And then use something that's on the mounting face of the hinge in line with the axis. So really this point is what you want, but halfway through. So let's again create a mate connector. We're gonna pick the end of that segment like this. Owner part is going to be the leaf, but then we're gonna move it in the y direction by length over 2. And now if I go back to my assembly, I've got these 2 mate connectors that are, I think, conveniently located right halfway on the hinge center line, but on the mounting face. So that would be a nice, easy to use thing. Anyway, I think that's enough for today. Let me know if that helped, and if there's any other specific things you'd like to see. Yeah, hope that was helpful, and see you next time.